Hi everyone, Kate Lynch here. Today I'm going to go over the Advanced Concepts presentation number 8. Okay. So for an intro, today I'm going to walk through the process for how nucleotides and ribose are made and show how these all come together to make ATP and they're used for DNA replication. Alright, so first I'm going to start off by explaining glycolysis. So this is what I made for our poster. I think it's easier for me to explain it every step by putting it on this PowerPoint, so I'm not holding up the giant poster. Alright, so to start out, we're breaking down glucose into pyruvate. So this is called oxidation. So we start up here, we can see this is glucose, and we're taking ATP, forming ADP, and so on. And then by the end, we find that we have a pyruvate. We actually have two pyruvates. So 2 ATP are in turn produced. It's actually 4, but we use 2, so then 2 are produced. And this is powered by 2 NADH. So the 2 pyruvates are formed, and then they're transferred to the mitochondrial matrix. And then we find ourselves in the pyruvate dehydrogenase complex. So down here is my drawing of this. So the pyruvate is converted into acetyl-CoA using pyruvate dehydrogenase. It's changing the 3 carbon to a 2 carbon, and this produces CO2 and NADH. This actually happens twice because 2 pyruvates are formed, so now we actually have 2 acetyl-CoA. So then where does this acetyl-CoA go? I'm sure you all know. It will enter the citric acid cycle. So it's coming from up here. We'll pretend the pyruvate dehydrogenase complex is up here and it's coming down and boom, there it is. And now we have 2 acetyl-CoA and they enter the cycle. And this will then produce 2-GTP, or which is the same thing as ATP. This also produces 3 NADH, and this actually happens twice, hence the 2 acetyl-CoA, so it actually makes 6. And it also produces 2 FADH2s. So this is important because all that, they're really important for transferring electrons. They're electron carriers, and you guessed it, it goes right into the electron transport chain or oxidative phosphorylation. So this happens in the mitochondrial membrane. The NADH and the FADH transfer electrons to the electron transport chain, creating a proton gradient within the membrane. This drives the production of ATP with ATP synthase. So then the 1 NADH actually equals 2.5 ATP, and then 1 FADH2 is 1.5 ATP. So when it's all said and done, like we did in one of our previous presentations, we end up with 30 ATP. So this is really great. We have 30 ATP, but there's actually so much more that goes on in forming ATP and repeating it and forming DNA and RNA. And this happens in the pentose phosphate pathway. So this is the really important stuff. So no ATP is consumed or produced in the pentose phosphate pathway. So it's actually a branch off of glycolysis. So we need to know that some glucose is shunted away from glycolysis and goes to the pentose phosphate pathway. So when we're making glucose or pyruvate from glucose, it's actually not all of the glucose that was available. Some of it's actually getting shunted away to this pathway, and it's happening simultaneously to everything that I just explained. So primary products are ribose 5-phosphate, and this is a substrate that produces in producing DNA and RNA. And then another primary product is NADPH, not NADH, NADPH. And this donates electrons, and it's used in anabolic reactions or building up, so like building up DNA, RNA, stuff like that. So just to continue, so there are actually 2 phases in the pentose phosphate pathway. There's the oxidative and the non-oxidative phase. So in oxidative, producing NADPH, this happens in the oxidative phase. So we start with glucose 6-phosphate, and that's broken down. And then we have the non-oxidative phase, and this is reversible. So this is what's really important in rebuilding everything, DNA and RNA wise. So this starts with ribulose 5-phosphate, and it's broken down into ribose 5-phosphate. So this is important because It interconverts sugars, and this is really great because it allows the cells to produce more ribose 5-phosphate, and this is used for DNA and RNA synthesis. So this is how DNA and RNA is made and how it's continued to be rebuilt constantly. And that is all.